Okay, so let's continue. So this time actually we are doing the things similar as before, but it is more troublesome because first for part A, we want to do sum to infinity of the question, right? But in part A, we are going to solve it for the values of k. So this one we have learned before, which is we use the t2 divided by t1 and also t3 divided by t2 to form an equation. Because it is a geometric sequence. Okay, so for calculation stuff, we may handle yourself. Okay, so multiply, expand, and so on. Alright? So after that, please check for each value of k whether they are able to form a geometric sequence. Okay, so you can check the sequence. So you see for case 1, it is a kind of geometric sequence. So we keep it. But for the second one, this one is not a geometric sequence. So that's why we need to reject. Okay, so let's go to part B. So part B, we only consider all the even numbered terms. Okay, even numbered terms. That means the second term, the fourth term, and sixth term, and so on, and then we find the sum of that. Okay, it means this one is a new sequence. So the original sequence means this one. Common ratio is R. Okay, if only even number sequence consider, that means it is a new sequence. Okay, so this new sequence is having the sequence in this way. First term is T2, second term is T4, third term is T6. Okay, so this is second term divided by the first term of the new sequence. So this is R, and then as the first sequence already multiplying R all the time. So if we make it alternate to make a new sequence, that means the common ratio will become R squared. Okay, R squared. R squared. Okay, because every time we multiply R and R. So we can use this piece of information to do the substitution. So if you remember correctly, this is the sequence. We got it from part A. Okay, first term is 32, second term is 16, but this time we start with the second one. So the A equals to 16. Alright, and then the common ratio is the original common ratio with a square, right? Square of the original common ratio. So the original one is 8 over 16 square, which is 1 over 2 square, 1 over 4. Okay? As a result, we can put all these into the formula, the required sum, then we just calculate for it. Okay, first term, T2. Common ratio, R squared, 1 over 2 squared, and then you can get the required sum. Okay, so basically that's it for the calculation and some sort of difficult question in this session. So we have one more thing to discuss. So this one is pretty interesting. Okay, so in Form 4, we have used another method to use recurrent decimal to change it to fraction. But this time we can use sum to infinity to do so. Okay, so if you get 0.3 with a dot on the upper part, that means you can use 0.3 plus 0.03, 0.003, and then 0.303, this one, and the fifth one. Okay, and then we can add without the end. Okay, so it is a kind of sum to infinity. So this is the first term. Common ratio will be second term divided by the first term. Okay, so you can get the value equals to 0.1. So put it to sum to infinity. First term, common ratio, then you can get 0.3 with a dot becomes 1/3. But there is a question which is more interesting. Do you know the value of this? What does it equals to? Many people say it is equals to 1. Do you agree? So there are many articles in the internet to discuss this thing. So that's the end of this part for the usage of sum to infinity. Okay? That's the end of Exercise Math World. See you next time.